So in this video, we're going to begin looking at how we go about graphing a linear equation in two variables where the line is written in standard form. And I've already said previous to this, standard form means some number times x plus or minus some number times y is equal to a number. And so if you look at the equation that we're given in this particular example, it's exactly in that form. It's 4 times x and then minus 3 times y is equal to negative 12. And often when an equation is given to us in this form, it's most easily graphed by using the x and y intercepts. And so if you look up at the top of the screen there, we have this example of this graph, and we have the x-intercept and the y-intercept. Now, what is the y-intercept? Well, we've seen previously the y-intercept is the point on the y-axis where the graph crosses the y-axis, or the y-coordinate of the point where the graph crosses the y-axis. And something very important happens anywhere along the y-axis. On the y-axis, x equals 0 always. For any point on the y-axis, x will always equal to 0. So if we want to find out where the graph crosses the y-axis, we simply have to set x equal to 0. And that looks something like this. When x is equal to 0, we get 4 times 0, which is 0. That whole term is going to go away, and we simply end up with negative 3y is equal to negative 12. We divide by negative 3, and we end up with y is equal to 4. So when x equals 0, y is going to equal 4 in this particular case, and we have the point 0, 4, which is graphed already there on the screen. Now, how about the x-intercept? Well, the x-intercept is the x-coordinate of the point where the graph crosses the x-axis. And on the x-axis, y is equal to 0 always. So let's see what that looks like. And again, if we want to find out where the graph crosses the x-axis, we simply have to set y equal to 0. So when y is equal to 0, then we'll get negative 3 times 0, which will become 0, and our equation will simply be 4x is equal to negative 12. Dividing both sides by 4, we get x is equal to negative 3. So when x is negative 3, y will be 0. When y is 0, x will be negative 3. And all we have to do then is plot that point. X is negative 3, y is 0. And if we wanted, we could look at what the slope is between those 2 points. We go up 1, 2, 3, 4, over 1, 2, 3. So we would say that this line has a slope of 4/3. Now, if we wanted to find another point on the graph, there's no more room to go up 4, but we can do the reverse. Down 4, 1, 2, 3, 4, over 3, 1, left 3, sorry. And you can see that this point also falls right on that line, and all we have to do then is draw the line through those points. And when we do, we get the graph of the equation 4x minus 3y equals negative 12. So we could have solved this for y and plotted using the slope-intercept form, which is always still a possibility. But sometimes, especially when the number on the right of the equation, that is negative 12, can be divided evenly by the coefficient of x, 4 in this case, or the coefficient of y, negative 3 in this case. So since negative 12 divided by 4 is negative 3. Negative 12 divided by negative 3 is positive 4. Since those divide evenly, it might be easier to graph this using intercepts. So we'll go on to another example of this. Once again, if you think you understand how to do this at this point, just stop the video, work through the example, and then come back to the video and check to make sure you're getting this correct. Okay, so we have our equation, which is 3x minus 2y is equal to -6. If we want the y-intercept, remember that at the y-intercept, x is always equal to 0. When we set x equal to 0, then the term the term 3x becomes 0, and we end up with -2y equals -6. Dividing both sides by -2, we get y is equal to +3, and so we have the point x is 0, y is 3, and we can graph that point. X is 0, y is 3. That is the y-intercept. If we're looking for the x-intercept, at the x-intercept, y is always equal to 0. So we set y equal to 0, then -2y becomes 0, and we end up with 3x is equal to -6, dividing by 3, and we get x is equal to -2. So therefore, when y is 0, x is -2, and we can plot that point. X is -2, y is 0. We can calculate the slope here by going up 1, 2, 3, right 2. So m is equal to 3 over 2. And if we wanted, we could find additional points by going up 3, right 2. Notice that all those points fall on the same line. Or we can go down 3, left 2, and again down 3, left 2, and once again you notice that all those points fall on the same line, and so this is how we graph an equation using the x and y intercepts. And once again, all I had to do is draw a straight line through those points, and I have graphed the equation 3x minus 2y is equal to -6. What does that mean? That means any point that lies on that graph, the x-coordinate could be plugged in, multiplied by 3, the y-coordinate could be plugged in, multiplied by 2. The 3 times the x-coordinate minus 2 times the y-coordinate would always equal -6. And so there are an infinite number of solutions to that equation, and they all fall right on that line. Okay, then the next thing that we want to do in this section is we need to look at horizontal and vertical lines. So remember what I said, x equals -3 is not the solution to an equation. It is a graph. It is the set of all points whose x-coordinate is -3. This seems to be very difficult for a lot of students to get. So a lot of times students want to put that at the x-intercept. That's fine. But then it includes every point, and there are an infinite number of them, that have an x-coordinate of -3, whether y is positive, y is negative, etc. We have an infinite number of points. All of the points have an x-coordinate of -3, and you'll see when we draw a line through that, we get a vertical line. All right, so x equals -3, x equals any number. The x-coordinate of each point on that graph is -3, and that will produce a vertical line. Next, we have this equation 2y minus 4 is equal to 0. Well, you may notice that there is no x in that. So what we would do, now on one hand, this looks like an equation that we would solve. And I understand that that is what makes this very difficult for students. They would get 2y is equal to 4. Dividing by 2, they would end up with y is equal to 2. And it seems that that's just one y value of 2 that solves this particular equation there. However, we're asked to simplify and then to graph this equation. What does y equals 2 mean as an equation? It is the set of all the points whose y-coordinate is 2. So if I were to start plotting points, and if all of their y-coordinates have to be 2, then this is an example, and there are an infinite number of them, not only the ones that I'm drawing here. There are an infinite number of points. All of the points have a y-coordinate of 2, and they will all lie on this horizontal line. So it's important to remember x equals a number gives you a vertical line. Y equals a number gives you a horizontal line. And if you have x's and y's together, then you're going to get some kind of a diagonal line. All right, let's go on to another example of this. Once again, this is student practice. You can pause the video, work through the problem yourself, and see if you're understanding what we're doing here. Then turn the video back on and check your results. Okay, x equals 4. What does that mean? That is a set of all the points whose x-coordinate is 4. We go to x equals 4. We plot a point. Notice that all of these points, not just the ones that I'm drawing here, but all points that have an x-coordinate of 4 will lie on this line, and all we have to do is plot a few of them and then go ahead and draw a straight line through them, and you'll see that we get a vertical line. Now sometimes we have to simplify and graph the equation. Again, 3y plus 12 is equal to 0. It looks like an equation that we're just solving for y and that there would only be one answer to. On one hand, that is correct. So we'll bring it over here. 3y plus 12 is equal to 0. Going to subtract 12 on each side. We end up with 3y is equal to negative 12. Dividing by 3, we get y is equal to negative 4. Y is equal to negative 4 because we're asked to graph this equation does not simply mean one number. What it means is the set of all points on a grid whose y-coordinate is negative 4. So let's go to a point whose y-coordinate is negative 4. Note all of these points have a y-coordinate of negative 4, not only the ones that I'm plotting here, but every point on the line, on this horizontal line, would be a solution to the equation y is equal to negative 4. And we draw a straight line through the points, and there we have the line y equals negative 4. So 3 things that we did in this section. Number 1 is we had to plot points in slope-intercept form. Number 2, we graphed equations of lines in slope-intercept form by first plotting the y-intercept and then using the slope to find additional points, drawing a line through the points. Second, we graphed equations in standard form. We did this by finding the x-intercept. We found the x-intercept by setting y equal to 0 and solving for x. We found the y-intercept by setting x equal to 0 and solving for y. We plotted the 2 points, drew a straight line through them. The third thing that we did was we looked at graphs of vertical and horizontal lines. X equals a number will always produce a vertical line. Y equals a number will always produce a horizontal line. And so we're done with this particular section and with this